Today, we are going to understand and simplify expressions with zero and negative exponents. So we've only dealt with positive ones, but exponents can be zero and negative, and they can even be fractions. But we're just going to learn about zero and negative exponents today. Let's explore what it might mean to have a zero or negative exponent by working with what we know with positives. So 2 cubed expanded is 3 2's multiplied together, which equals 8. 2 times 2 is 4, times 2 is 8. So 2 squared is 1 less 2. It's 2 times 2, because it's 2 being multiplied by itself, and that equals 4. 2 to the first is just 1 2. And I think it's pretty obvious that that equals 2. So what does 2 to the 0 mean? Well, if you look at these, we're always dividing by 2. Like, we get one less factor of 2. So when we divide by 2 from this 2, we get, what is 2 divided by 2? We get 1. So another way that you can think of this is over here. What number can be part of any multiplication problem without changing the answer? So you can multiply by 1 and it will always get you the same answer. So let's write a little 1 on each of these and see what happens. We get rid of a 2 each time, and then by the time we have no 2's, only the 1 is left over. So anything to the power of 0 will equal 1. You could do this with 5. You could do this with 1,000, and you would find that it would divide by whatever the base is, and that you'd be left with 1 at the end. Now let's look at negative numbers. So a positive exponent is usually shown as repeated multiplication, and a negative exponent, well, the word negative usually means it's the opposite. So it's going to go kind of the opposite direction, and it's going to be shown as repeated division. Let's just keep on going. Let's keep our pattern. If every time we move down 1 in our exponent, we divide by 2, what's 1 divided by 2? Well, I'm going to write it with a little fraction bar. Oh, let's zoom in a little bit. Okay. I have 1 divided by 2. It equals 1/2. Let's do it again. Divide by 2. And here's a way to show that you're dividing by 2 twice in a fraction. You put both those 2's on the bottom and multiply them. So 1/2 divided by 2 equals 1/4. And you know that if you split a half into 2 pieces, it equals 1/4. Then divide by 2 again. We're going to show this as dividing by 3 2's this time. And 2 to the negative third power equals 1/8. Now let's look at the whole big picture. Sorry, I have black and green here, but let's look at the whole big picture, and you notice that these are 1, 2, 4, and 8. And then on the other side of the 0 power, you have 2, 4, and 8. But this time, they are on the bottom. They are the reciprocal of the positive power. So we're going to write these words down. A negative in the exponent means that it's the reciprocal of the positive power. So we're going to write reciprocal. And then any number to a negative power will be 1 over that number to the positive power, just like we saw above that it was 1 over 2 and 1 over 4. Any number to the 0 power is 1. I love this rule. This one's my favorite because you can get rid of so many things with this rule. You don't even have to deal with exponents anymore because it just equals 1. Let's do some examples. So any number to the power of 0 is 1. So on B, x to the power of 0 equals 1. Done. Okay, I'm going to show you a numerical negative example. If you have a negative power, then you're going to do 1 over the positive power. If this were a variable, then you would just leave it. But this one is not, so we can actually simplify this further. We know what 5 squared equals. It's 5 times 5, which equals 25. So this is equal to 1/25. anytime you have a number being raised to an exponent, if it's not too large, if it's not like to the 42nd power or something, you should simplify that number and get rid of the exponent. Okay, we're going to do this 7y to the 0. Now, any number to the power of 0 is 1, but what is this 0 to? Remember that it only applies to the thing that's right there to the left. So this 7 has an invisible exponent of 1. So when we do this, it's 7 to the first power, which equals 7, times y to the 0, which equals 1. And 7 times 1 equals 7. So that's our answer on that one. Let's go down and we'll do the same thing, but with a negative exponent. So write your little 1 before you get started on the problem. And then we're going to write 7 times, it helps me to write the multiplication problem out. And then this is 1 over the positive exponent. Now that looks ugly. So we're going to remember what we know about multiplying by a fraction. And I would make this first number into a fraction, just make it over 1. And the way you multiply by a fraction is you multiply across. So 7 times 1 equals 7, and then 1 times y to the 4th just equals y to the 4th. So if you didn't want to show the fraction multiplication, what you could just think of this as doing is the negative brings it to the bottom, and then the positive means it stays. And then you'd have 7 over y to the 4th, and you wouldn't have to do that whole writing it as the reciprocal and then multiplying. But you should know this because this is the reason why that works. Okay, then this one, it's just a quick example. We're going to do more of these in the future. But the parentheses mean that that 0 applies to the whole thing. So whatever 7y is, I don't even care because it's to the 0 power and the whole thing equals 1. Okay, we have 3 more examples, but these are toughies. Buckle your seatbelts. Okay, before you get started, you should write the power on every single number. So I'm going to write 4 to the power of 1, and then 2 doesn't have a power, so that's to the power of 1. Now, just like we learned before, we're going to put all of the positive powers on the top and the negative powers on the bottom. But what do I do with that negative sign out in front? There's only one negative, so I'm going to make my whole thing be negative to begin with. The whole thing is negative. And then on the top of my fraction, I put my positive power. So I have 4 and 2. And on the bottom of my fraction, I'm going to put my negative powers, but they're positive now. Yay, they became positive. But remember to simplify your numbers, and you'll have 4 times 2, which equals 8 on the top. That wasn't so bad, was it? If you remember to write the ones at the very beginning, you will be a lot less likely to make mistakes. Okay, let's go over here to D. Okay, I'm going to write this as a 1. Once again, the whole thing is going to be negative. There's only one negative, so we're going to make the whole thing negative. And I see a negative exponent in here, so I'm just going to make sure that this is a fraction bar. Okay, W to the 0, it's a 1. And 1 times anything makes it the thing. So I'm just going to cross that out. Remember, you can only do this when it's multiplying, though, because multiplying by 1 keeps the number the same. Adding 1 makes it bigger, though, so be careful. Okay, W squared is positive, so I'll put my 9 on top because it's a positive power. W squared goes on top. And then that X to the negative third moves to the bottom, so I'll put that down there. That looks really giant and ugly. I think I was thinking that this problem would end up with a larger answer than it would be. Okay, so it should look like that. I just made it a little more compact. Okay, moving over here. Let's add in our powers. There's only one thing that doesn't have a power. That's the 7. So we're going to move down the negatives. And there are no zeros, so we're just going to keep everything else on top. So on top of our fraction is the 7. The X squared, and nothing else. On the bottom is the W, make that a positive power now. And Y, okay, Y to the first is just Y, so I'm not going to write that one. And then Z. Okay, so this is not so bad. Here are some things that help. Make sure to write your ones on everything that doesn't have a power, and think about each letter or number individually and decide where it goes. and what happens to it. And then that will make it seem easier. Deal with it piece by piece. Good luck.